Yeah, there we go, okay. So pretty much since the beginning of recorded history, people have been trying to find better and better ways of sending each other secret messages. And the technology's progressed in fits and starts over the ages, somewhat faster usually in times of war than in times of peace. But in the last 50-odd years of the development of the microchip, we now have machines for encryption that are vastly more powerful than anything that ever came before. Of course, equally then we have vastly more powerful tools for stealing data than there ever were. Oops. Why would we want to encrypt stuff? Well, even as individuals today, your data about you is probably one of the most valuable things that there is about you. Any sort of information, personal information, financial information, technical, is a target for whole industries of bad actors that are out to steal your data and profit from it. And you may have been at Keelan Johnson's talk this morning about the importance of understanding the threat against you and the need for intelligence to do that. So over the last, especially 10 or 15 years, there's been a real desire to improve the levels of security. You know all about the push to try and encrypt the whole web with Let's Encrypt and so forth. And I think we're about 85% encrypted at the minute, HTTPS. And you may also have heard Dan Callahan's talk this morning, great talk on WebAuthn. So, you know, people are innovating means, thank you, of authenticating people on the web. But what about other use cases? I wouldn't be away from the web. If you're anything like me,
there's not anything displaying at the moment.
Oh, yeah, that's right.
Oh, that's good.
If you're anything like me, you find that even in this context, you are often sending emails, say, sharing files, without actually making any effort to protect that information through encryption. There are a lot of tools available for that sort of thing, and as you may be, especially if you're working in a big company like a bank or something, already using within the company things like an S-MIME-based authentication system. But what about if you say you're a smaller company, you don't have the budget for that, or you want to communicate outside that particular boundary? What do you do? So this talk is really wanting to try and talk about a particular tool. It's just one tool in the space, GNU-PG. I want to have a look at what it is and does, why you might want to use it, why you might want to avoid it, but why it's worth knowing about either way. Let's maybe try and get a bit of an overview before we dive into the detail. Just a word in terminology. GNU-PG, or GPG as it's known, is a particular implementation, and the GNU implementation of PGP. Just in case there's a confusion about the terminology, PGP is pretty good privacy, and it was invented by a chap called Phil Zimmermann something like 25 years ago. And basically, it's a tool for encrypting stuff. Quick overview then. GPG takes, it's a variant on the theme of public key infrastructure. So you may remember from being a kid and reading books about codes and encrypting stuff, you need a key to encrypt a message. With public key infrastructure, you actually, when you say a key, you actually get two keys, a pair of related keys, a public one and a private one or a secret one. And the way it works is, if I know your public key, I can send you an encrypted message. And also, if you send me a message and sign it, if I have your public key, I can verify that it is from you and hasn't been modified in transit. Here's an example just using email. And here we have Bob is going to send an email to Alice. I hope that's readable. And he's going to sign it as indicated by the little blue tick icon in the corner of the window there. Because he signs it, Alice is going to know that yes, it really came from Bob and he is inviting her to a party. Or she may want to send him some information that she doesn't want anybody else to read. So as well as signing the email, she encrypts it, clicking that button there, And the little padlock indicates that this is going to be encrypted for Bob and only him to read, he being the recipient. And then when Bob gets that, he sees that it came from Alice and that it was signed and encrypted. So he knows, first of all, that she sent it to him, it hasn't been changed en route, and nobody else has read it. Okay, so if this tool is here and it does all this stuff, why are we not all using it already? Especially, it's been around, as I say, over 25 years. Well, there are problems with GPG that have prevented its widespread adoption. For one thing, you actually have to install the software yourself. Typically, you get a computer out of the box, it does not have this. Or, well, some Linux distros, you may well have it out of the box already. You may well have to install graphical tools for managing the key data and that sort of thing. You'll often have to install plugins for email clients. And installing software, that's going to put 90% of the potential users off already. Key management, though, is a more fundamental problem. There are more fundamental problems. With GNU, you do have to manage your own keys, and key management is not necessarily a trivial problem. It's one of the more important problems of any sort of cryptographic activity. Additionally, there's no forward secrecy. What that means is, if I manage to somehow get a hold of the emails, for example, or any other messages that you send that are encrypted, I might not be able to read them now, but I can record them. And if at any time in the future I successfully steal your private key, then I can decrypt those messages and read what was said. Also, the web of trust, as they call it, so this is GNU's model of, GPG's model of trusting other users, doesn't necessarily scale very well. So GPG takes a model that's a bit different from the way things work on the web that we're familiar with, HTTPS encryption, where you have root servers that delegate authority to CAs, certificate authorities, which in turn create certificates that authenticate individual websites. So that sort of hierarchical model is familiar. GPG is more of a peer-to-peer distributed model. It's more, as somebody said recently to me, I thought was quite good, it's more of a Git approach than a subversion. And I think also that perhaps another reason why it hasn't been more widely adopted is people think, oh, cryptography, you'd have to be a crypto expert to use those tools. I'm not going to bother, or I'll get round to that sometime. That, at least, I think, isn't the case. The whole point of the tools is that the people who do understand the cryptography try and write these things so that the rest of us can use them. So if there are all these problems, why are we even talking about it? I'm going to contend that it's still worth knowing GPG. Yes, there are numerous new tools and libraries that have come out in the last few years that try and do a better job of some of the things that GPG does. But just yet, it's quite early days, perhaps, for many of those. And certainly, at least now, they haven't yet sort of come together into an ecosystem where there's a clear and widely agreed choice of tools to use for various different purposes. So I think it's a wee bit premature to retire GPG just yet. It is also, it certainly works within the constraints that we've talked about, and it is still the most widely used tool of this type, probably around the world. It's used every day. Just as one sort of random example, a little while back, the company I was working for, one of our customers wanted to share some of their proprietary source code with us so that we could do a proof of concept together. And they didn't want to take that and stick it on Dropbox or some public cloud like that. And their first question to us was, what's your GPG key? So for that sort of reason, I think it is still worth knowing the tool. And finally, if for no other reason, it's worth knowing because you can use it as a baseline for comparison when you're coming to evaluate these other things. I have some links at the end that you can go do some investigation if you're interested in that sort of thing. Okay, so that's enough of an overview. Let's talk briefly about getting GPG, and then we'll have a look at setting it up and using it. You may well have it already, as I say, depending on some Linux distros you'll have it. Otherwise, it's easy to get with your favorite package manager. The GPG itself, on Linux you can do, well, it obviously depends on what your package manager is. On Mac, you've got brew install GPG, or GNU PG, I think it is. On Windows, there's GPG for Win, which is a bundle of various different tools, GPG itself, some graphical key managers, there's plugins for Outlook and that sort of thing. If you're on, if you're a Thunderbird user, you'd probably want to get a plugin for it called Enigmail, which works with GPG to encrypt Thunderbird email. You need to do a little bit of config once you do download it. Just for the sake of time, I'll just skip over that, a bit boring. Again, links at the end. So let's take a look then at how to get started once you've got it. You can't do very much with GPG out of the box until you create your first cryptographic key. So I'm going to illustrate this process in as much detail as I can manage in half an hour. Again, don't try and memorize it. There'll be links at the end for where there's various websites where this sort of thing has gone into in great detail. But we'll try and give enough of a flavour to give you a steer. And I'm going to try and steer a middle path between the sort of simplest thing you can do and some perhaps more secure but maybe a bit more complex stuff in order to try and offset to some extent the key management problems that we talked about earlier. So out of the box, if you do ask GPG and you say create key or generate key, you actually get not one key but two. And the reason for this is because it is apparently a cryptographic principle to not use the same key for two different jobs. So we talked about signing and encryption. So GNU out of the box, GPG gives you a key for signing, first of all, and a subordinate key underneath that. This is a master key and this is a subordinate one for encryption. So the A is for encryption, the S is signing, the C is certify, which is when you're signing other keys, which is involved in the web of trust, as we'll have a look at it a bit later. And you can certainly do that and get GNU and just use that key and it'll work. Certainly it works, but what if your laptop, say, with your key on it gets stolen, or one of your co-workers just goes and grabs your key off it? You now have to let everybody know that that key has been compromised and start from scratch again to rebuild a new key and rebuild your web of trust. You also have to, hopefully you've held on to, when GNU creates this thing, it creates a certificate that you can use to revoke it, so you can publish to a network of key servers the fact that this key has been stolen and is no longer any good. So to avoid that sort of problem, we're going to take a slightly different approach, which is we'll not have one subordinate key but two, one for signing and one for encryption. And the role of the master key is going to just become to act as a master to certify things. And in fact, yes, sneakily I'm going to throw in a third subkey. Just there is a use case which you can use GNU for SSH authentication, so that you can actually have a separate authentication key. So you generate these three subkeys. They're going to be the ones for day-to-day use. And then you take your master key offline and store it securely in a safe in the basement with guard dogs and things. Now that it's safely out of the way, you can use this set of keys day to day, and if anybody does steal these, you can take your master key out of the safe, use it to revoke those, which can be published for general information. Use your master key to generate a new set of keys and carry on working. And people who have your public key and have been trusting it for some while do not have to give up the trust on that key. They can continue to trust that, and you don't have to rebuild that web of authentication. Okay, let's dive in and do this. I don't do live demos, and I don't type too fast, so I have a little video here, so we'll just follow through it. It is a bit command liney, or it's very command liney, but it is a software developers conference, so come on, that's not going to scare you guys. So here's Alice. Again, hopefully this is readable enough. And Alice wants to create a GPG key. So she asks GPG to do a full generate key and selects expert mode, because then she gets a full list of all the types of key that you might want to create. Now, if you know you want this, there is a variety of elliptic curve keys which are available, but that probably take too much to talk about right now, so I'm just going to stick with RSA, the warhorse, trusty warhorse of authentication. But I'm going to set your own capabilities so that I can do that agree with the key creation. Now, so it creates a key and it says, okay, sign, certify, and encrypt initially, because I've asked for my own capabilities. Now, I only want certify, so I'm going to use these toggles, typing S to get rid of signing and E to get rid of encrypt. And that leaves me with just certify, which gives us the master key that we wanted. So I now click Q to say done with that, and it asks me how strong a key do you want. So unless you've got some good reason, I would suggest let's pick the strongest key available, which is 4096 bits. And having chosen that, you then need to tell it how long this key is going to last. And this is going to be our master key, so we don't really want it to expire, I would say, too quickly. So I'm just going to select 0 to say never expire. There's argument about this and probably no real right answer to that one, but I'll suggest that anyway. It asks for a confirmation, and when you say yes, then it says, okay, who is this a key for? So it's going to be a key for Alice. You enter your email address and a password, which is going to be used to protect the key when you use it, so that other people can't maliciously impersonate you. And you're done. You now have a GPG key. It's identified by this 40-character fingerprint. A shorter version of that is there, and you can refer to it with that. And you can see it's an RSA key, and there's your public key. Okay, now we need to add the subkeys for day-to-day use. And the process for that is very similar to what we've just seen, so I'll not bother going through it all again. You edit the key in order to add the subkeys to it. So you pick Edit Key, tell it what key it is. You can use the hex ID, or if it's unique enough, you can give it the email address or even just the name Alice. And again, you pick Expert Mode to get that complete list of key types that are available, which is this here. The first time round, you pick number 4 because you want to add a signing key. You go through the same sort of process again. You maybe want to pick an expiry of, say, maybe a year or 6 months this time. You can always renew the expiry time later on if you want. 6, then the second time round to pick an encryption key. And 8, the third time round to, there is no authentication option here, so you have to set your own capabilities again. And then use the toggles, like we saw before, to switch off the stuff you don't want and leave yourself for authentication. Yeah, the next thing you want to do, well, you don't have to, but you can add other email addresses. So again, in the edit key, you can add UID and add alternative email addresses for, say, you get work and a personal one. And now that's our keys created. Before we progress anywhere, the next step is to get everything securely copied off, backed up. So we need to export the keys. And we do that again at the command line by, first of all, exporting the secret key, and then just the subkeys into a separate file. And we'll see why that is needed in a little moment. And you want to back these 2 files up, and indeed a third one, which is that revocation certificate that I mentioned. Whenever you create these things, it also creates a certificate that will allow you, if the worst comes to the worst, to publicize the fact that the key's been compromised and should not be trusted. The top one is the one you stick in the safe. The second one we'll use in a moment. This also goes somewhere secure, but probably not in the same safe, because if the house does burn down and everything's lost, and you've lost your key, you need to, again, tell people that that has been compromised in some way, so you probably want to have a copy of that somewhere else that you can get at, even if the house is destroyed. All right, now we now want to delete the master key so that we can use just the subkeys for day-to-day use. And this is where it gets a bit yucky, because GPG doesn't actually let you do that. So what we have to do is delete the whole thing, everything we've just done, and then get the day-to-day keys by importing back into GNU that subkeys file that we created. Deleting the keys is done in 2 steps. You delete the secret key first of all, and once you've done that, you can then delete the public key. And then you've got to remove and destroy the working directory where GNU did its work, because there is still the disk is still there, and if you've been working on the disk, then the bytes are still there, can still be there, that would allow your key to be stolen still. So you don't want to just do a remove on the directory. You want to securely remove it, and this is perhaps where it gets particularly yucky, because obviously that's very platform dependent. It depends also on whether, for example, you've got a hard disk or a solid state drive, which you may just not be able to remove the information. So here I'm going to give you the first of a couple of options for doing things in a more secure way. And the first option is do everything that we just did on a boot from a live disk, because then everything's done in memory. Nothing touches the hard disk at all. And when you get to the point where you need to delete your key, you can just switch the machine off, assuming you've got everything securely backed up. Now we can get our machine set up for day-to-day use by importing the keys back into GPG. It tells us that it's brought everything in, and we have our laptop set up for day-to-day use. Option 2 for doing things more securely, when you generate the subkeys, instead of just storing them on a regular pen drive or whatever, you could actually put the subkeys for day-to-day use into a smart key, cryptographic smart key, like a YubiKey that was mentioned this morning by Dan. And then the keys themselves don't even live on the laptop. They stay on a little key on your key ring, which they cannot be extracted from. But again, it's an option. I don't want to give the impression that you must do that, and I certainly don't want to put you off trying it out. All right, that's our keys generated. What can you do with GPG? Well, just briefly before we look at that, actually, let's just have a look at some of the tools that are available. You do get a few things with GPG on the command line. There's a useful one called a GPG agent, which is a little daemon process that runs in the background and memorizes your password so that you don't have to reuse it every time you send an email. Holds your password in memory. But there are also various other tools, like this is a GPG tools for the Mac, which give you graphical ways of managing all this stuff. So here's Alice's key just after she's created it. And you can double click on it to get the details of the key. You can see that you can add a graphical user ID, or right click on it to get a menu of options. So what can you do with it? Email we've already talked about. File encryption is also available. You can certainly do it at the command line, but again, with those graphical tools, typically into your file manager, you'll get some integration so that a menu of choices becomes available to encrypt and decrypt files, for example. I mentioned that you can also use GPG for SSH authentication. I'll not go into the details too much, but basically you set up a few environment variables, and the GPG agent can masquerade, or indeed can act as, an SSH agent. So that lets you use your GPG key as an SSH key. And when you restart the GPG agent, then your SSH command will list a public key for you to copy onto an authorized keys file on your remote server, and it's actually your GPG key that's being used. What else can you do? Passwords, for example, or passwords, access keys, that sort of thing. Pass is a little utility which uses your GPG key to encrypt small amounts of data. So you initialize it with the key you need to use. You add passwords in a sort of file system-like hierarchical path. Enter the password, confirm what it is, and now you've got it encrypted with your key. If you do just the pass command, you get a nice little tree which lists all of the the data that you've entered. Passwords are hopefully on the way out, but they'll be around for a time yet. Release verification. If you saw Glenn Russell's talk earlier, you may want to get hold of Vault and try it out. How do you know you've got the right software? When you download the Vault software, you don't just get the zip file, you get a checksum file. How do you know you can trust that? HashiCorp sign that checksum file with their public key. So you import their public key into your GNU PG. You use the GNU to verify the signature on the checksums file, which means you can now trust it, and now you can use SHA-SUM to verify the zip file, and you know that you have the real Vault. A couple of other things. You can sign GitHub commits. I know some people do that. I don't bother myself, but you just tell it the key you want to use, and then it's as simple as adding -s to your commit command. And just going a wee bit out there, apparently you can actually use your GPG key as a Bitcoin key and generate Bitcoin transaction addresses from it. I know nothing about Bitcoin, so I don't know why anybody would want to do this, but I just throw it in because it is a thing that can be done. You need the right elliptic curve key to do that. And finally, just a quick word on building the web of trust. Say Alice wants to get, or Alice receives a message from somebody who claims to be Claire, who Alice doesn't know. How can she trust Claire? Two ways. Either Alice trusts Bob, and Bob has signed Claire's key, or Alice trusts enough people partially, and if enough people have partially signed Alice's or Claire's key, then again GNU PG will say, right, that's valid. You can trust that. Okay, I'm going to wrap it up there. Just as a random example of reasons why you might want to think about this or another tool. Just last autumn, some researchers revealed that for several years past, China Telecom had been quietly hacking the BGP protocols at points of presence all over the United States and sending vast amounts of traffic on its journey across the states, rerouted through their servers in mainland China. So you never know where your mail's going or your messages are going. I think it really is worth thinking about it, encrypting it so that wherever it goes on its way, you can have some confidence that it gets to the end without having been hacked. Thanks.